Everyone, this is Vin, and welcome to the June 2025 Algebra 1 live stream review. The Regents is tomorrow at 1:15 p.m. and we're going to go through the June 2017 test, and just want to first say hello to everybody that is currently here. I see that we have, we have a lot of people here in the chat, so hello to just all of you. Hello to Brittany, Patricia, Tice, Carter. I see a lot of people lighting up the chat. Yeah, shout out to all your teachers, that sent you here. I appreciate you all, for being here and on the stream. It, really does mean a lot. And I'm just happy to be here with all of you. So let's see. We'll just get rolling here and get moving. But we are, 7:30 is the time we're set to start. But June 2017, I put a link in the description, and that's what we're going to be going through. So, I was just studying with my video. Awesome. I'm glad the videos are helping. I'm going to keep making Regents videos. I am taking the channel like in a, not completely different direction, but I have some ideas for next school year that I'm going to try some stuff out. Little update. I am currently studying I have to get something called my 30 above, which I should have had done by now, but I have to take a test in, let me just see so I can make sure that I'm aiming this at the camera. So taking one on information systems, principles of management, and biology. So I have, a little work ahead of me in the summer. And this weekend, I'm also applying for a program called Math for America. So that's what my game plan is. So, I'm going to keep making my usual content, but my videos are, I'm going to try making stuff that's like also useful throughout the school year as well. Because I'm getting a lot of views during the school year, but I want to try to help you all out more as the school year is going on. Oh, videos are helping you understand. I'm so happy to hear that. That's truly the goal. My goal is to get as many people through this Regents as possible. That is definitely like my big goal. Geometry, I did live stream, last week, and we're still waiting on the grades for a bunch of the kids. Oh, thank you. I'm happy to help at Nicholas. So, All right. Awesome. So moving on here. So let me just see as more people come in, because I did say that I was going to start at, I was going to start at 7:30. So I'll give people 2 more minutes to join, because I don't want to say, 7:30, and then I start, a different time. Look, the key is to get off you all some words of wisdom, no matter what level you're at. Some of you may be coming into this stream like, hey, I'm going to maybe get a 90 and up, or, am I going to even pass this thing? As long as you keep at it and you keep practicing, then keep practicing, and it's going to get you to where you need to be. All right, it's a slow marathon of a game here, and that's what we're going to do. I will explain, though, chat guidelines, because it was an issue with geometry. I'll only say, please feel free to ask questions. I'm going to do my best to answer as many as possible, but please be nice to one another. All right, if anyone's not nice, I'm going to have to read the chat. I do have to get moderators going in the future, but if anyone's really not nice, I'm going to just have to mute you or send you away. So please, just hopefully maybe there won't be trolls, but there's usually at least one. But that's all right, nothing we can't handle. Okay. Cool. All right. So another minute and we will get started here. All right, let me see. All right. So let me see. All right. Yeah, any address related stuff I'll just mute, because I don't know what that's about. All right. Cool. Here we are. So let's get rolling here. So the test is June 2017. We're going to go on to the multiple choice, starting with question 1. Okay, and then this one, let me see. Got to zoom out a little bit. This is one of those graph story questions. So, all right. We have question 1. To keep track of his profits, the owner of a carnival booth decided to model his ticket sales on a graph. He found that his profits only declined. So here's the big part. Only declined. And maybe I'll make this not as... So I'll do... Yeah, I'm just getting this set up here. Actually, 5 should be okay. All right. So his profits only declined when he sold between 10 and 40 tickets. Which graph could represent his profits? So declined means the graph goes down. Okay, so this is what we're looking for. Where does the graph go down? But it's got to be between 10 and 40. Okay, so this is big, between 10 and 40. So if you look, see from 10 to 40, here the graph is not going down. It's staying the same. So this one's out. From 10 to 40, the graph is going up. So choice 2 is out. From 10 to 40, is definitely dropping. So we found that the profits only declined between 10 and 40. See how it's going down then up? So right away, choice 3 is it. This answer choice is no good because between 10 and 40, graph goes up and back down. So not the case. Okay, louder. All right, I'll try to be louder. People could do like an audio check here. Could people hear me, see me? Just let me know if something's out of whack. All right, so next up, we have the formula for the surface area of a right rectangular prism is given here. Area is 2 times length width plus 2 times height width plus 2 times length height, where L, W, and H represent length, width, and height, respectively. Which term of this formula is not dependent on the height? So this phrase could be a little tricky to understand. So which term of the formula is not dependent on the height? And that means that if we change the height, it's going to change the term. Okay, so depends on means like, let me think of it a nice way. So like y equals 2x plus 1. I could say here like y depends on x. So this is like we call the dependent variable. And y is the independent. I'm sorry, no, this is the, let me start that sentence over. Y depends on x. X is the independent variable. Like x could be anything. But whatever x is, y is going to change. So this is like the dependent variable. And x is the independent variable. So as x changes, y changes. So which term of this formula is not dependent on the height? Well, you got to look at the one that doesn't have an h attached. So you see like 2LW, no matter what h is, this is not going to change. Okay, so this one here is the one that's not dependent on the height. Okay, if we change the height, 2 times LW stays the same. Like changing h does not change this. This one will change because if you, let's say h is like, 2, and then you make h equal to 5. If you multiply by 2 and then by 5, you're going to get something different. Okay, same thing with this. But then the whole area has variables of h. So the area does depend on the height. Okay, if I draw out a rectangular prism like this, changing the height of the rectangular prism, if like the height goes up or the height goes down, that's going to change like the surface area. Okay, but it's not going to change LW. LW is like the area of the bottom. Okay, if the height goes up or down, this bottom area is not changing. So that's why it's 2. Tricky question, definitely. It's annoying when they open with like the weird stuff. All right, 3 is easy if you know how to type in the calculator. So let's say you know how to type this in. So I'll go to the calculator and let me make sure I close out some of the other stuff we don't need. Okay. Okay, so here's the graphing calculator. We want a graph of y equals square root x plus 2. So for one, I go to the y equals, and I press square root is second x squared, and then I have x minus 2. And then I press graph, and there's my graph. Okay, that's y equals square root of x minus 2. So we got this. I bring this over here, and I just look and I say, all right, it's got to be that one. Okay. If you know here, like y equals square root x looks like this. When you replace x with x minus 2, this is like y equals square root x shifted right 2 units. Okay, so to the right 2 units. So you see how this goes 1, 2, and it's going to be here like this. Okay, so that's why it's choice 4. Cool. The Regents, it's normal to be scared. I mean, if you haven't taken this Regents before, it's nothing weird about being scared. I mean, anything like competition based could be scary, but you know, you just show up and do your best. And that's the best you could do. So the equation, the student used the equation y equals negative 0.09 x plus 9.24 to model these data here. So like, I don't know, just imagine something like this. Cutting through. What does the rate of change? The rate of change, just think y equals mx plus b. The rate of change is the m value, the slope. So this is slope, y-intercept, and this is the rate of change. Okay, some people might recognize, you know, if I write this, m equals y2 minus y1 over x2 minus x1. Another way of saying this is like, you know, the change in y over the change in x. But what I think of with these questions is like the units here. The y units is like the average number of hours of sleep per day. And then the x is age. So average number of hours of sleep per day, and then per years of age. See how the units are showing up here. But one thing to think about is positive slope, your line goes up. Negative slope, your line goes down. Vertical line has an undefined slope, and a horizontal line has a 0 slope. And I like to call this, this is slope guy, okay? Slope guy gives one of you a nightmare, then slope guy did his job. But what's going on here is the average number of hours, you can see like the average number of hours is decreasing because the graph is dropping. Okay, so increases we could cross out here. Like 1 and 3 are not going to be the answer. All right, it's going to be 2 or 4. But you have to just know that the slope is the rate of change. So the slope is the negative 0.09. And people might think like, wait a minute, what does the negative mean? The negative slope means decreasing. Okay, so we could say that it's decreasing here at 0.09. So question 4, we could go with choice 2. All right, this one here, once again, is going to work out to choice 2. The average number of hours of sleep per day decreases 9.24. This is like the initial. The y-intercept is like the initial amount. So this basically tells you like, you know, like, oh, how many hours of sleep? Well, here they're like starting it at 10, but like at birth, it'd be like, all right, you sleep like 9 hours on average per day, but that's kind of not true. You sleep more than that when you're newborn. But this is the initial value, not the rate. The rate is the slope. So 4 is 2. All right, moving on. So let me get this. All right, 5. Let me zoom in a little more. So Lynn, Jude, and Anne were given the function f of x, and they were asked to find f of 3. Lynn's answer was 14, Jude's answer was 4, and Anne's answer was plus or minus 4. Well, more than one of them can't be correct, because a functions have, let me not say unique, have, I should say, let me maybe phrase it like this. Sorry, I'm just like also, I'll rephrase it a nice way. Each x has only one y value. Okay, so this is for functions. So this is just something good to know about functions. You cannot have repeating x values going to different y values. So there's only going to be one f of 3. All right, so f of 3 is negative 2 times 3 squared plus 32. Now, people mess this up when they do this without a calculator. You have to know, though, order of operations, that you do parentheses exponents first. So the negative 2 outside, we do later. We're doing 3 to the second is 9, and then plus 32. But now we're doing negative 2 times 9 is negative 18, plus 32, which gives us 14. So Lin is the only correct one. All right, but this is an Algebra Regents, and you do get a calculator. So for this one, you could just go to the calculator, and you could type in exactly what you see. Negative 2x squared, and then plus 32. You press second graph and go to the table. And f of 3, see how the y value here is 14. So this tells you f of 3 is 14. Okay? Cool. How many Regents questions multiple choice do you need in order to pass? I want to say it's like around 14 or so is safe. I think 14 is about right. But, you know, aim as high as you can. But yeah, the Regents is very passable. I have faith, you know, people could definitely pass this thing. I've been teaching I've been teaching for 12 years, and I've had students that, let's say, failed it multiple times. I'm not going to name their names. I'll keep them anonymous. But they kept at it. You know, they kept trying, they kept going, and they eventually passed the thing. All right. The key is you need that like perseverance. Okay. It's tough. I know it's discouraging when you're struggling and all that, but, you know, do your best tomorrow. You know, don't say like, oh, when's the soonest I could leave? Like, stay at the test and like really focus on or lock in, as you would all say, you know, while you're there. All right. Which expression is equivalent to this? So this is a good formula to know. A squared minus B squared equals A plus B times A minus B. So difference of two squares. So here, the math that I'm doing in my head is I'm going, all right, square root of 16x to the 4. And I go, the square root of 16 is 4 because 4 times 4 is 16. And then the square root of x to the 4 is x to the second because x to the second times x to the second equals x to the 4. And then the next term is 64. The square root of 64 is just equal to 8. So then looking at the answer choices, I say, all right, so from here to here, I'm just taking the square root of the first term is 4x squared. And then I go plus or minus. The square root of the second term is 8. But now, how about this? If you just want to pass. So this is the coming up. I just want to pass method. Okay, the I just want to pass method for this question is we go to the calculator and we type in the question. So we go here, let's say 16x to the 4 and then minus 64. And then we run through all the answer choices. So let's say I pick a wrong answer. Like, all right, 4x squared minus 8 squared. All right, so we have this. And then we have 4x squared plus 8 times 4x squared minus 8. Okay, so this is the question, wrong answer, right answer. If I go to the table, here's the question. See how the y values don't match? But for the y3 column, negative 64, negative 64, negative 48, negative 48, 192, 192. They match. Okay, so you could also get to the right answer just by plugging the question. This goes in y1, and then this would go like y2, y3, y4, y5. It's time, but you have 3 hours. Okay, you have 3 hours for the test. So you could definitely, get there. All right. So let's see. So Vinny collects, maybe that's me. Vinny collects population data, P of H, about a specific strain of bacteria over time in hours H as shown in the graph below. Which equation represents the graph of P of H? All right, so this one, like honestly, I mean, if you just know what graphs look like, so I'm like, all right, lines are linear. Those are like y equals mx plus b. quadratics smile at you like y equals ax squared plus bx plus c. The x to the third or h to the third one's cubic. So like, let's say like y equals x to the third. Looks kind of like this. So like probably not this one. And then exponential. So exponential growth looks like this. And then like exponential decay looks like this. So like, I'm always like tempted to be like, all right, this one. So something exponential is like y equals a and then like b to the x. Like this. So I'm like, all right, probably this one. But once again, calculator. You could plug these values in and see which ones give you the match. So we go to the calculator. Y equals. And you just start typing in the answer choices. So let's say I do 4 times 2 to the h. But I'm going to use x. And then choice 2, I'm going to say is wrong. But I have 46 over 5. I could press alpha, y equals enter. And then 46 over 5. Hit the right arrow times x. Whoops, plus 6 over 5. I could just do 6 over 5. And see if I press graph, that I get 0, 4 for the correct answer. 1, 8, 2, 16, and I get 332. This one, choice 2, gives me the wrong stuff. If I plug in choice 3, I'm going to get the wrong stuff. Choice 4, I'm going to get the wrong stuff. So that's how I know choice 1 is good. Okay. Please learn how to use the calculator. The calculator will honestly buy you, like, it's not necessarily going to pass the whole Regents for you, but it is going to boost your score tremendously. All right. If you could use that calculator, you're going to be in really, really good shape. All right. Awesome. So moving on. Yeah, shout out to all the teachers that sent you all here. So tell your teachers I said thank you. If they posted it in their Google Classrooms and all that, just tell them I said thanks. All right. 5th time. All right. Well, 5th time could be the charm. I'm rooting for you. I hope you, like I said, I hope everyone here passes. I mean it. All right. What is the solution to the system of equations below? So this one, yeah, could be a little tricky. This one, I would say get them in y equals mx plus b form. So this one's already good to go. This one's the one that's a little funky. So here's the algebra. So distributive property, you go 1, 2, 3 times negative 2x. I'm doing 3 times negative 2 is negative 6. And then the x tags along for the ride. 3 times y is 3y, and it's a plus 3y because I have a positive 3 times a positive y, and then equals 12. If I want this in y equals mx plus b form, I'm going to move the negative 6x over. I'm going to go plus 6 and then the x on both sides. So see you later to this. 3y equals 6x plus 12. Because this is a positive 12. Or you could say 12 plus 6x, but remember, commutativity of addition, a plus b is equal to b plus a. You could just switch those. Then divide everything by 3. And this gives you y equals 6 over 3 is 2 times x plus 12 divided by 3 is 4. So now we have these two lines. We have y equals 2x plus 4. And we have y equals 2x plus 8. Now you'll learn this more in geometry, but these lines have the same slope. So these two lines here are actually parallel, which means they're never going to intersect. And if they don't intersect, they don't have any solutions. Okay, the other way, so this would be like graphically, is just drawing this out. If you drew out, 2x plus 4 would look like this. So make that a little neater. Like 2x plus 4 looks something like this, and then 2x plus 8 will look a little something like this. And you're like, oh, they don't intersect. But algebraically, I could set them equal to each other. And if I have 2x plus 8 equals 2x plus 4, I could go minus 2x on both sides. And now these cancel. And then this tells me 8 equals 4, which is not true. And when you get something this absurd, you say, all right, then no solutions. Okay? Cool. All right, that's that. All right, so for these mappings, function or not function, we have like, this is kind of like the x and the y. We cannot have, the rule is like no repeating x values. This would be like, a teacher had a good analogy. They said, if you go to a vending machine and you were to go to a vending machine and you're like, all right, here's my vending machine. So the vending machine is here. And then like, this is the code to buy whatever you want. And then like your snacks are here. Okay. If you were like, hey, I really want like, I don't know, Takis. And then you type your code, like code, you get Takis. And then your friend goes right after and they're like, ooh, I want Takis too. And they type it and then like celery comes out. They would be like pretty mad. All right. Like, oh, the machine is broken. So a function is like a machine, but if you type in a code, the input, it should give you exactly one output. All right. But the problem here is something like February. It's like, this is like the friend getting Takis and the other friend getting celery. It's like, wait a minute, this is not a function because February has two outputs, 28 and 29. Okay, so just remember that. No, the Regents is for all of New York State. Yeah, it's like one of those. Well, actually, they make the test up in Albany, I think. Pencil on the bubble sheet, sign your declaration, and you go over the free response in pen except graphs. Okay, follow those rules. But every school has like maybe slightly different rules, but those are pretty universal, I think. Don't leave anything blank. All right, which polynomial function has zeros at -3, 0, and 4? So I'm going to say this. Roots and factors have opposite, or have an opposite. Make it grammatically correct. Have an opposite relationship. If your school does it in pen, then great. But I know like our school does the bubbles in pencil. But maybe there's like, your school has like those like high-tech scanners. So I don't know. Yeah, I'm pretty like New York State takes this test. This is like a New York State thing. Oh, and anyone who's here, if this is helping and you're not subscribed, consider subscribing and help me grow this channel. I think we're close to 43,000. So, yep, just trying to get to the next level. It's a slow game, but it's a fun game. It's been a fun ride. Oh, wow, we're 2 subscribers away from 43,000. I wonder if there's 2 people here that are not subscribed that could get us there. So, what should you eat in the morning? I don't know, something good. Don't eat like just donuts or something. Eat something that's going to give you energy. Unless like if you have a donut, like eat it in like the last hour so you just get like a sugar rush for the end. Thank you at Nicholas. I appreciate you subbing. So, oh wow, 40. Wow, a lot of people just hit the sub button. Now we're over 43. Thanks. We made it. I appreciate you all. Thank you. Thank you. You're all awesome. Okay. So what I mean opposite relationship means if I have, let's say, let me start with something that's like kind of nice. How about, I don't know, x squared plus 5x, something random. So this is random. This is not part of the question. So random x squared plus 5x minus 6 equals 0. You know, like how you look for 2 numbers that have a sum of 5 and a product of -6. And then you're like, all right, x plus 6 times x minus 1. Because 6 minus 1 is 5 and 6 times -1 is -6. And then you set each factor equal to 0. So you set this one equal to 0 and you set this one equal to 0. And then this gives you x equals -6 and x equals +1. So this is how you go from equation to roots. You factor and then see how the factor x plus 6 gives you a root. Like these are the roots here. These are the roots, or I could even say the zeros. Okay, they're called the zeros because that's where the graph hits the x-axis. So this parabola would hit it, let's say -6 and 1. if, I just pick something random here and not really drawing this to scale. So when they tell me this, I'm like, all right, x equals -3, x equals 0, x equals 4. I go backwards. I'm like, all right, that means the factor was x plus 3. And this I could say x minus 0, or I could just say x. So I could just say x. And then +4 would give me a factor of like this, okay, which means my original function, f of x, would just be the combination of these three factors. So you see how we have the x showing up first, and then the x plus 3, and then the x minus 4. All right, so this is like the concept, the conceptual approach, and this will give you choice 3. However, you're like, oh no, that's scary. Fortnite terms. I never really played Fortnite, but I hear great things. I know one of my cousins plays, and back in the day, so for the chat, this was the game everyone played. I played this in so let's see, it was like 2001 to like 2006. That's when I played that game. So Counter-Strike was the game of the times back in the day, before Fortnite was born. That was like the Fortnite, the OG Fortnite was Counter-Strike. I think it's called CSGO now, but I don't know if it's like completely out now. But yeah. But thanks for taking me, trip down memory lane. Okay. So we have another way of doing this. Let's say you're like, I'm scared. That algebra was terrifying. Oh no. What you do though, this takes time, but this is the I just want to pass method. You type in all the answers. You're like, okay, x plus 3. Let's say choice 1. And then you got x squared plus 4. So if we look at this, this only has one root at -3. Okay, so that's why 1 is not the answer. And you got to go through the answers one by one. So then you get to choice 3, and you're like, all right, x parentheses x plus 3, close parentheses, and then x minus 4. You press graph, and this one has a root at -3. See, at -3, at 0, and at 4. And if you're like, hey, I didn't bring my magnifying glass, you could press second graph, and look what happens at those values. At -3, we get 0. At 0, we get 0. And at 4, we get 0. So choice 3. Okay. No, all right. So at Ariana, multiple choice, you only like you bubbled it correct. You bubble the answer correct, you get full credit. If you say eeny, meeny, miny, mo, and you choose 3, you get 2 points. If you say, hey, when in doubt, pick C, and you choose choice 3, you get 2 points. In the free response, though, if you have no idea what to do and they say, do it algebraically, and you're like, no thanks, I'm going to do it on the calculator, you get half credit. So they say that in the rubrics. It's like, you solved it by a method other than the one we asked you to. Then they give you partial credit. Okay, so it's better to get partial credit, though, than 0 credit. So do what you got to do. All right, these questions here are a little bit annoying. Let me get the quote. Abe Lincoln quote. Axe. All right, let's see. Here, let's get, I don't know if this will paste right in here. It did. Okay, there's our Abraham Lincoln, all right? Give me 6 hours to chop down a tree, and I'll spend the first 4 sharpening the axe. Remember that for the rest of your lives. Okay? What that means in this context is like this question, you have to think. Okay? You have to read, maybe reread. Don't just be like, 12. Oh, there's 12. Oh, there's 14, 40, 250. That's the first one I see that has, in this case, that would actually work. But, think your way through these. All right? These are not like the easy questions. These require a little more thought. Okay? So, we have Jordan works for a landscaping company or a landscape company during his summer vacation. He is paid $12 per hour for mowing lawns and $14 per hour planting gardens. He can work a maximum of 40 hours per week and would like to learn at least $250 this week. And here we go. M is the number of hours mowing lawns. So the $12 per hour mowing lawns belongs with M. And then the other variable here, G represents the number of hours planting gardens, and that's 14 per hour for planting gardens. So the blue belongs with the blue, purple belongs with the purple. Which system of inequalities could best be used to represent the given conditions? Okay, so this, like I said, is a lot, but you got to sharpen the axe here and think. All right, think carefully. So notice they all have 12m plus 14g. 12m plus 14g like this. So if we set up, let's say m plus g and also 12m plus 14g, think about what this means. This is the sharpen the axe phase. He makes $12 per hour mowing lawns, 14 per hour for planting gardens. So this is like money earned. Okay, if you do 12 times like his hourly wage times like how many hours he works mowing lawns, plus the hourly wage for gardens, and then times G, the number of gardens, this is like money earned. But he wants to earn, so this is the earn part. He wants to earn at least $250. So at least, think about this, okay? So you really want to think here, like at least. So at least means he has to make greater than or equal to that amount. Okay, so if he wants at least 250, that means his money earned has to be greater than that or equal to that. If we go less, then that's not at least 250. That's at most. Okay, so at most, if you think about that phrase, at most would be less than or equal to. All right, so just think your way through these questions. All right, I know it can be tricky, but it's what you have to do. All right, let's get Abe Lincoln out of here. Sorry, Abe. Okay, cool. So that's that. And now the other phrase. How do we deal with the other part? Well, he could work a maximum of 40 hours per week. So that means M plus G is like hours worked. Okay, because M is number of hours mowing lawns, G is number of hours planting gardens. So if he could work a maximum of 40 hours, then he works less than or equal to 40, which makes the answer choice 1. Okay? Get back into Counter-Strike. I used to be like decent, but there were like always those people who were just, I don't know, this might be like unpopular opinion, but like first person shooter games, I think there were just some people who have like insane reflexes. Cause like I played a decent amount, but there were some people who were just like silly good at the game, who were like really, really, really good. And it was like, I don't know. I mean, it was like cool to see them go to work, but all right. Question 12. Anne invested $1,000 in an account with 1.3, so we have this, 1.3% annual interest rate. She made no deposits or withdrawals on the account for 2 years. If interest was compounded annually, which equation represents the balance in the account after 2 years? So this is the formula to know. So this is the formula. So here, like, all right, how much money does she have? Well, she invested 1,000. So P is like the investment, like the initial amount. And then 1.3%. Percent means out of 100. And if you're like, uh-oh, decimals, like, I don't know, maybe you were remote during the COVID years when they taught you this. And I don't know, maybe you were busy playing Fortnite or CSGO. So, I'm sorry, I'll stop talking about CSGO, Griffin. I'm just trying to make it light here. So yeah, we'll get back to the math here. All right, let's see. So let's say you can't do that math. 1.3 over 100. All right, is 0.013. So 0.013. All right, otherwise like elementary school. So let me just fix this. 1.3, I'll put a 0 here as a placeholder. If I divide by 100, I go 1, 2. So that's why it's 0.013. So this would tell us the R value. Okay, R is 1.3%. And since it's an investment and the account is growing, we're going to go with 1 plus. Okay, the interest rate is 0.013, and T is the time in years. So to the second power. So 12 is going to be choice 2. This matches up with this one. Oh, at Mr. Cellini, hello. I stopped by your live stream just before, and I hit the thumbs up button. So awesome work. Yeah, shout out to Mr. Cellini, everybody. If anyone needs help, getting ready for, I want to say, was it Global, Mr. Cellini? If you're still here, you could chime in. But yeah, definitely pay him a visit. He's got a really solid channel here. And a fellow YouTuber, fellow teacher. So putting in some excellent work. And yeah, channel's doing well. And I hope to just keep seeing it growing. So good luck this season. All right. So next up, we've got this one here. Which value would be a solution for x in the inequality here? So this one, the backup method I'll show. Like backup method is called this like brute force. Brute force is you just plug in all the answer choices until you get something true. Okay, so like let's say I plug in negative 13. So I'm like, all right, x equals negative 13. And I'm like, all right, 47 minus 4 times negative 13 less than 7. And then this becomes 47. Negative 4 times negative 13 makes plus 52. And then you're like, all right, that's 99 is less than 7. You're like, oh no, not true. So then you're like, not this one. And you just do that for all of them until you get to 11. And if you plug in x equals 11, I'll do this in a different color, would give you 47 minus 4 times 11 is less than 7. See how I just plug in for x? That'll give you 47 minus 44 is less than 7, and 3 is definitely less than 7. So you could just brute force plug in if that's how you want to do this. But the more elegant solution, or let's say this was a part 2 question, well, for those, you would have to solve for x. So for those, you would go, all right, minus 47. And I'll do this where we're dividing both sides by negative so we could see the sign flipping. So you get negative 4x left is less than 7 minus 47 is going to give you negative 40. Now let's see, like, say low key, you just don't know how to do that math in your head. There's no shame in it. You get a calculator. You could, and don't get old. What was it? Oh yeah, 7 minus 47. Like, you could just type this in. Like, negative 40. Okay, so if that math is slightly annoying, then just do what I did. All right, now next, we divide by negative 4. Okay, so divide by negative 4. But when you divide, all right, if you multiply or divide, so if you multiply or divide by a negative, the sign flips. Whoops, flips. Okay, so when I divide by negative 4, I'm going to say x greater than negative 40 divided by negative 4 is 10. So I need something greater than 10, and the only answer choice greater than 10 is 11. So that's how we know choice 4. Cool. All right, this one's all concepts. So correlation coefficient. For one, calculator. You ready? If you're doing correlation coefficient questions, press mode. Make sure stats diagnostics is on. Okay, so you go stats diagnostics on. For this question, it's all theory based. But for the non-theory based, make sure it's on. Okay, so correlation coefficient, you're at negative 1 to 1. So at 0, this is like no correlation. Okay, but the closer we get to negative 1 and positive 1, so if we're here, we're strong. Like here is like weak. And then 0 is like no correlation. So which one represents the strongest? So which one is like, has the closest distance to either 1 or negative 1? And just looking at them has to be this. Because this is like in my head, I'm like, oh, 0.9 is 0.1 away from 1. The other ones though, like this is 0.5 away. This is 0.7 away. If we go minus 0.7, then we get there. And then this one is 0.2 away. So this one's only 0.1. It's the closest. Okay. So 14 is 1. All right. So why did I do this? So I did the June 2017 because I have videos on like every Algebra 1 Regents dating back to like, I don't know, like early 2020s. And most teachers, when they review in class, just do a lot of Regents. So I went far back so that there's a good chance you've never seen this. Okay, that's why I did it. All right. Yeah, lock in, everybody. I hope everyone makes their teachers happy. Oh, from Queens. Hello. Going far out to Queens. Queens is nice. It's a nice borough. All right, let's see here. Height in inches of 12 students are listed below. Which statement best describes the spread of these data? All right. So this one, honestly, to get a feel for this question, I wound up typing stuff in. So let me type this into the stats. So stats, edit, and then I'll just type it in 61. Enter. 67. I'm just going to type these in because that's like nothing exciting. 72. And then we got 62. And if you're like, wait, where are you getting that from? I just type in like 65, enter. 59, enter. 60, enter. 79, 60, 61, 64, 63. Okay. Then stats, calculate, go to the right, one variable statistics. All right. And you get all this stuff here. Okay. So these are the values we're getting. Now, what I like to do with this stuff, so the average here, the average is 64.41. So let me just copy some of this stuff down. So this, here, let me actually copy it here. All right, so that went, and we scroll down. Okay, and then I'll shrink this. Just because like to do this by hand is like kind of tedious. All right, so shrink, put this over here. All right, so there it is. This is all the data we're gonna need. So the mean is the average, that's this one. Okay, so the average is like 64.416 repeating. And then we have the minimum value. So for these, what I like to do is sometimes I'll even draw this out. I think when I did this, I looked and I was like, all right, we're going from a minimum value of 59 and the max is 79. When you subtract those are 20 away from each other. So if I started at like, let's say 59 and I start counting by twos, so I go, let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You know, like this is where 79 would be. And if I count by twos, see, I get 61, 63, 65, 67, 69, 71, 73, 75, 77, like this. I'm going to turn this into a little, box and whisker plot. So see, we got 59 is the min, 60.5 is like here. Okay, so that'd be 60.5. And then the median is at 62.5. So that's like here. And then Q3 is at 66. And then you ready for this? The max is at 79. So this box and whisker is like pretty nuts. And you're like, whoa, look at this. This is nuts. So like 79 is an outlier. And this affects the standard deviation of these data. Standard deviation, I'm not sure. Someone could fact check me on this because I'll be honest, I haven't taught Algebra 1 since 2016. So I'm just like doing math like as I do math. Like I'm just like, all right, do math. Well, so this would have been the Regents my students took way back when. Like now they're long graduated. So here, outlier just means it's like way far out there. And think about it. It's the height in inches of 12 students. So if you have a student in the class who's 79 inches tall, okay, 79 inches, if I multiply by 1 foot over 12 inches, or basically just divide by 12, this means that the kid is, was that 6'7"? Yeah, because 72 inches, so 72 inches is equal to 6 feet. Right, so then that would be like someone who's like 6'7". Like that's I mean, I've had students in the past that were 6'7", and not a lot, but they exist. Yeah, they're an outlier. That's like, whoa, that's really tall. The standard deviation is like the average distance from the average. So you see how like the average here worked out to like 64.416. That's because like that made it like really like, I guess, tall, because you have one kid who's like super tall, and it doesn't mean like, whoa, that's a pretty high average. I'm like, yeah, because this kid is like super tall. Yeah. But yeah, cool. Now the data set is skewed because 59 is the only value below 60. That's not why. The median is not 59.5. The median is 62.5. So like definitely not evenly spread. So it's got to be 4. All right. So we have an equation that's going to represent the function here. One thing to know is like y equals ax squared, and this is positive, means like your graph is smiling at you. So it's like happy. Okay, if you have y equals ax squared, and this is a negative number, then the graph is sad. Okay, it frowns at you. So I'm like, oh, this one's sad. It has a negative in front. So like this one's out because it has a positive 1/2, and then times the x plus 15 squared. And same thing with this. So just process of elimination alone will bring it down to 2 and 4. What you could do from here, though, vertex form. So this is like, standard form. I believe this is called standard form. So standard form. But then vertex form is when you have y equals a times x minus h squared, and then plus k. So here, notice the vertex, the turning point, is at 15, 25. That's your hk. All right, so that means our equation is going to be y equals a times x minus h is 15. And it's being squared, and then plus k is 25. So you see how like this is a common mistake, x plus 15? Like people change the sign of h and they keep the k the same. They mix those up. So for this one, it's got to be choice 4. Here like this. All right, that'll get you there. Another trick. You ready? So this one's a little more advanced. Is like this is the point, what's that, 12.5 that would be? Halfway between 10 and 15 is 12.5. So this looks like the point 10 comma 12.5. And then this looks like the point 20 comma 12.5. So what you could do is you could even type in all the answer choices. I mean, that also works. So there's like a few options here. You could go, all right, let me see. You type in, let me just bring this up a bit. But you type in the answer choices, and I'm like, yeah, choice 4 is correct. So I'm like, I think choice 4 is the best. So we go negative 1/2. You know what? I'll write it like this. Negative and then alpha y equals enter. 1/2. And then x minus 15 squared. So we got this plus 25. And I press graph, and I'm like, oh no, I can't see anything. And that's because this goes out to 25 on the x, and it goes up to 25 on the y. So watch this. I'm going to press window. The x minimum, I'm going to make 0, because you see how the x starts at 0? And then the maximum x is 25. And then y minimum is 0, and the highest y value on the graph is 25. Whoops, so I'll go 0 for the min, 25 for the max. And now I press graph, and you see how I get this over here? And if I want, I could press second trace the maximum, the high point. I go to the top of the hill, I press enter just before the top. I go over the top and I go down, enter, enter. See, and I get 15, 25. So like this one is definitely good. Okay, and if I want to see here, when x is 10. Oh, and if this happens, see how, oh no, fractions, those are annoying. You go to mode and you change your answers from auto to decimal. And now it'll look good. See, when x is 10, y is 12.5. When x is 20, Y is 12.5. If I wanted to, though, I'm going to show you another trick. Stats, edit. I clear this stuff out, and I write in 3 points on my parabola. Okay, so I'm going to write in 10, and then the Y value is 12.5. Okay, then I'm going to do 15.25. So the Y is 25 when the X is 15. And then 20, and then 12.5. And this is a nice trick you're going to see. I press stats, calculate, and quadratic regression is number 5. Okay, there's a lot of other ones here, but 5 is the one I want, quadratic. So then enter, enter, enter. See, and it gives me my information, but in standard form. So like that's the only catch here. It's like not amazing, but it tells me my A value is -1/2. And I could be like, ooh, my A value is -1/2, and it like, you know, gets you closer. So all good tricks. All right, more quadratics. The Regents, Algebra 1, the Regents, they love quadratics. I don't know why that's like their favorite. Oh wow, 1,200 people stopped by. Thank you so much for the support. I hope you all do well tomorrow. And yeah, if you haven't yet and you've been here, if you've been here and this stream is helping, consider subscribing. This stream is going to be as long as this Regents takes. I am going to finish this Regents. Okay? Yeah, the test is old, just like me. 2017, back when life was simple. Okay. Which statement is true about the quadratic functions g of x shown in the table and f of x given here? So we have actual function and this one. So the vertex, remember this? So this is vertex form. So f of x, if I write this here, is x minus 3 squared plus 2, tells me my h is equal to 3 and my k value is 2. So this is the vertex. Okay, is at 3, 2. But they do not have the same vertex. See how the vertex for g, so for g of x, the vertex is 3, -5. That's the turning point. See, that's where the y values kind of mirror over this one. So they don't have the same vertex. Do they have the same zeros? No, oh, but here it is. They have the same axis of symmetry. That's true. Because they have the same x coordinate at their vertex. So the axis of symmetry is a line in the form of x equals k. And actually, I shouldn't say x equals k is probably going to be a little confusing because it's actually equal to the h value here. See how like your x and your y? So this is like also your axis of symmetry. Or it tells you your axis of symmetry is x equals 3. So this one has an axis of symmetry at x equals 3. Okay? Cool. An axis of symmetry is a vertical line, and it's going to be passing through the point where x is equal to 3. So here, if I have this, let's say this is here. Let me change colors here. So here's our axis of symmetry. And if I had a few of these points, like let's say 0, -4, then like 1, -1. I'm sorry, 0, +4. Let me start that over. 0, let's say this is +4. So like 1, 2, 3, 4. And then I had, let's say 1, -1. And then 2, -4. 3, -5. Like this. You see how the vertical line here, this is the line x equals 3, cuts this parabola in half. Okay? So, yeah, AP tests are definitely harder than the Regents. That's the main class I teach at high school is AP Calculus BC. That's definitely something tricky. Completing the square, yeah, I could go over completing the square. Let me see. Is there any questions on this Regents that complete the square? You know what? If I come across one, whoops, all right, it went fast here. Let me see. Are there any other quadratic things here? Yeah, you know what? When I get to a quadratic, if they say, hey, solve it, I'll do, I'll also show completing the square. All right. So given the function here, f of n defined by this, which set could represent the range. So the range is the y values. Okay, so for this one, what we could do is just start building it up. All right, so you got f of 1 is equal to 2. And this is like, if this is the rule, f of n equals negative 5 f of n minus 1 plus 2. This is when n is equal to 1. See, I plug in n equals 1, and like it would start me here. Okay, but when I plug in n equals 2, that gives me f of 2. So we get f of 2 equals negative 5 times f of, and I get 2 minus 1 on the inside. Now, one thing here is like, this is a function value. This is not f times 2 minus 1. This is f of 2 minus 1 plus 2. So this becomes f of 2 equals negative 5 times f of 1 plus 2. But this is the part that's maybe a little tricky. F of 1 is equal to 2. So I could just get the next value here by just plugging in. So I get negative 5 times 2 plus 2. And negative 5 times 2 is negative 10. Plus 2 is negative 8. So see how like my y values here start out at 2. And then my next y value is negative 8. And what this is telling me here is like, okay, we have 2 and then we have negative 8. But this one doesn't include the 2. So like right away, I'm like, all right, it's looking like choice 2. But maybe I do one more to be safe. So f of 3, now I plug in n equals 3. And then like f of 3 will give me negative 5. So like, see, this is the rule. So this is the actual, think of this as like, this is the, you know, acting as the function here. So when we plug in negative 5 times f of, and I plug in n minus 1, but when I do 3 minus 1 here, I get 2, and then I get my plus 2 at the end. But now I have negative 5 times f of 2 is equal to negative 8, and then plus 2, so this makes 40 plus 2, 42, and you see that gives me the next value here, which is positive 42. Okay, so definitely this one. All right, that's an annoying question. All right, you ready? So this one, you could be like, hey, do the algebra. And you're like, hey, just calculator. All right, I'm just going to use the calculator. So for this, if you don't want to do the algebra, even though you're at the Algebra Regents, you go like this. You go, all right, left side is 4 times x minus 7. And the right side is 0.3 times x plus 2, and then plus 2.11. All right, you graph these, and I'm going to press zoom 6 just to put the graph back to normal. I'm like, hey, they intersect. And then I press second trace 5. Second trace 5, and I scroll. I go in the neighborhood, I press enter 3 times. 8.3, choice 1. Okay, so for this, once again, you don't even need to know like how to do the algebra. All right, the multiple choice, once again, if you know how to use the calculator in the multiple choice, it gives you such an advantage. So be good at that calculator. So x equals 8.3. Okay, so this is like y1, and this is y2. All right, but what we could do is we could actually do the algebra here. So let's say you're like, hey, show me the algebra. So, all right, if I'm going to show you the algebra, then you distribute. So you're going 4x, and then 4 times negative 7 is minus 28, equals 0.3 times x is 0.3x. Let me get rid of this stuff. Okay, so we got this. And then plus, just think 2 times 3 is 6. So then we get plus 0.6. And then we get plus 2.11. All right, so you got 4x minus 28 equals 0.3x. And think of that as like 0.60 plus 2.11 is going to give you 2.71. And then from here, now we just do some algebra. Subtract 0.3x on both sides. So minus on this side. And we get 3.7x. Here I could go plus 28. See, though, this is like already starting to get kind of annoying. So plus 28 cancels this. These cancel. And then 2.71 plus 28. I do 2 plus 28 is 30. So I get 30.71. And then just divide both sides by 3.7. All right, and if you ask the calculator, I mean, hopefully the calculator doesn't talk back to you, but if you do 30.71 divided by 3.7, you get 8.3. Okay, so that's it. That's all there is to it. All right, converting units of measure. Complete factoring. All right, so let's see. All right. All right. So moving on. Anyone scared for tomorrow? Well, yeah, I was saying it before. I hope people are okay. It's normal to be nervous and scared, but you'll be all right. All right, just show up and do your best, and you'll be okay. Yeah, algebraically is pretty nice. It's a good option. All right, so a construction worker needs 120 cubic feet, or feet to the third power, of dirt using a wheelbarrow. One holds 8 cubic feet, and each load takes 10 minutes to complete. One correct way to figure out the number of hours. Okay, so we want this to be the units at the end. We want hours left. So this means units have to cancel. Like I said before, like converting feet to inches or inches to feet. True story. So I am 6 feet tall. How many inches tall am I? Well, to convert using this method, I multiply by 12 inches, but over 1 foot. And the reason I do this is 12 inches is equal to a foot. So this is like really, this is really equal to 1. Okay, so 12 inches equals a foot. So when I do 12 inches divided by a foot, this is really just like multiplying by 1. And when you multiply by 1, your value doesn't change, only the representation. So, but what does happen is feet over feet cancels. You want the same unit to be up as it shows up down here. And then you see how now I just do 6 times 12 is 72, and the only unit left is inches. So that's kind of the idea. We want to look for the answer. That's going to give us like hours at the end. Okay, so equals hours, and then equals hours. Those are the units we want at the end. The problem here, though, feet to the third over feet to the third cancels. But then minutes times minutes is actually going to be like, yeah, like minute times minute is really like square minutes. Okay, so not this answer choice. We want hours. So this one's out. Feet to the third times feet to the third is no good, because that would make like feet to the 6th power, which is kind of crazy. All right, so that's out. Same thing. Feet to the third times feet to the third. Oh, Jorge, thank you so much. You're scared. Well, it's normal to be scared. I don't really know. I gotta look up I have to have my Gen Z translator here, because the last time I got fooled, a kid tipped and he got me to say something that wasn't so nice. What does it mean? Am I foolish, eccentric? Is the informal. No, I wouldn't call you a fool. I think you're all right. It's normal to be scared. Unk. I know unk means uncle, right? I learned that last year. That one's still in. So yeah. Okay. Yeah, that one is. Yeah, it's that's the only way, because a kid got me the other day. He got me to say something bad, and I was like, "Oh no." That's what it said on Google. Oh no, does it mean something worse? Uh-oh. Is it going to break my heart? Should I just not look it up? My students are going to tell me I can't say a bad word. I can't say a bad word. That's why I didn't actually say it, right? Well, let's see. All right, this will be like a little brain break. All right, Reddit. Wait, in hockey, a brute. Oh wait, these might be like old people chiming in. Oh, okay. All right, yeah, that might be bad. Okay. Well, I'm glad I didn't say it. It's not appropriate. All right, yeah, don't say bad things, even if it's like Gen Z code. Okay, but hey, you know what? You're all giving me the real education here. All right, no, I'm back. So, all right, this one's out because feet times feet is feet to the 6. But now watch this: feet to the 3rd over feet to the 3rd, this over this over this, and we're left with just hours. So it's got to be 4. Is that like a new trend? Like people tip and then they say something terrible? No, yeah, I saw it on Reddit. It's here. Let me okay. Oh wow, a lot of thumbs up. Why are everyone supporting it? Oh no. It's like one of those things. It's like, oh, like thanks, but oh, you said a bad word. Yeah, let's stick to it. I have to take an official stance, and I would say I would rather people stick to the rules and be nice than like throw me money just so they could say bad things. Okay. So, all right, cool. So one characteristic of all linear functions is that they change by. Okay, so you ready? Linear functions, they rise and run by the same amount every time. So they rise and run by equal differences over equal intervals. I really didn't like this question because for this one, it's like kind of like weird language. The newer, so equal differences over equal intervals. So it's like it's going up by the same amount. And like if we go like count by the same interval here. So like if I'm going like equal spaces here, I'm going to keep going up the same amount and then over the same amount. Factors means it's like multiplying each time. So that's not it. Unequal factors, like no, it's not going up by factors. It's going up by this like, equal differences over equal intervals. All right. So rising and running by the same amount. We say that linear functions have a constant rate of change. All right, so I guess from that one, yeah, Reddit is where I go. But okay, sorry, I'm still on that. Oh, completing the square. Someone asked about completing the square. You ready? Okay, completing the square. Here it goes. I'm going to leave a space. So completing the square, what you do is you take your b value. And what I mean by b value is, you know how we have like ax squared plus bx plus c equals 0? Like your b value is your coefficient of x. So I'm like, all right, b equals -8. You take half of the b value and you square it. And you add that number to both sides. So half of -8 is -4. And if we square it, we get this. Okay, so let's see. So we're going to add 16 to both sides. So I'm also trying to monitor the chat. So whatever that half of b value squared is, you add that to both sides. And the reason why they call this completing the square is because now this is what we call a perfect square trinomial, which means when we factor it, we look for two numbers that have a sum of -8 and a product of 16. We're going to get matching factors. So we get -4, -4. -4 plus -4 is -8, and -4 times -4 is +16. On the right side, we get 10 plus 16 is 26. And now we get x minus 4 squared equals 26. Because when we multiply something by itself, we get the same thing squared. Okay? So, let's see. Now we take the square root of both sides. But this is a big idea. The square root of x squared, don't say x, is plus or minus x. Okay, square root of x squared, I'll say this like more advanced. But later on, you say the square root of x squared is absolute value x. But for algebra 1, just say plus or minus x. So what we do here is when we do the square root of x minus 4 squared, we get x minus 4 equals plus or minus square root 26. You have to throw in that plus or minus. See how all the answers have the plus or minus? And now the goal is to solve for x. You just go plus 4 on both sides. Now this gets people a little confused. They're like, uh-oh, plus 4, plus or minus. So that just means positive 4 plus or minus square root of 26. Okay, and that would give you choice 2. But let's say you're like, oh no, I can't do that math. I'm scared. All right, I'm going to show you another magic trick. So let's see here. So x squared minus 8x, I go 4 plus square root of 26. So I write 4 plus square root of 26 and I get this number. I'm going to show you a trick. You press store alpha math. You could store this as the letter A because now every time you write alpha math, the letter A, you get that number. And now I just plug in. I do x squared minus 8x, but I'm going to do the answer squared and then minus 8 times the answer. And if we did this right, we should get 10. It's like, hey, I got 10. And then you could also do it for 4 minus, not plus, 4 minus square root 26. So you do this, store it as, let's say, alpha apps for the letter B. And then I do that answer squared minus 8 times the answer. And I also get 10. So choice 2. All right. The formula for blood flow rate is given by F equals P1 minus P2 over R, where F is the flow rate, P1 is the initial pressure, P2 is the final pressure, and R is the resistance created by blood vessel size. All right. Which formula cannot be derived from, this is a tough one. Okay, because you have to know the algebra for this. So you got this. And I mean, I guess you could just plug in numbers that work. You could be like, all right, P1 is equal to, I don't know, let's say 25. And be like, P2 is equal to 7. And then you're like, all right, 25 minus 7 is equal to like 18. You're like, oh, how about I say R is equal to 2? And then say this would equal 9. So like capital F would be equal to 9. And then like you could just plug these numbers in to like all the answer choices and see which one's true and what's the only one that is not true. And if you do it that way, you'll get choice 3 most likely. Let's see. I think it's like, yeah, 2 equals capital F is 9 times 18. Like, no, that's not, that's why this one is like the answer. But if you're like, hey, I want to see the algebra, then if you're solving like this out, like let's say you're solving for P1, you cross multiply and you get P1 minus P2 times 1 is P1 minus P2 equals F times R. And then if you're solving for P1, you just add P2 to both sides. Okay, so let's say we go that route. We just add, yeah, if we're solving for P1, we add P2. We get P1 equals FR plus P2, which is this one. So this one can be derived. If we're solving for P2, so we could also go like, all right, P1 minus P2 equals FR. You could go plus P2. And now P1 equals FR plus P2, and then go minus FR on both sides. And then P1 minus FR equals P2. So this one is true. And then here, if I'm solving for R, so let's say I take this equation here, and I want to solve it for R. Well, P1 minus P2 equals FR. If I'm solving for R, I just divide both sides by F. And then this is also true. So we want the one that's not true. So definitely 3. All right, the problem with 3 is when you solve, you're not multiplying, you're dividing by F. So, all right. Here we go. So another question about quadratics. They really like quadratics on the Algebra 1 Regents. All right. Oh, we're an hour and 20 in. Was geometry tough? I think geometry was okay. I mean, there were a few questions that were maybe a little funky, but I think it was like pretty fair. It was like standard for the most part. So I'm excited to see how my students did, and all of you in my YouTube students. So let me know if any of the geometry crew is here. 78 out of 86. That is really good. That's impressive. I mean, if you just do the percent directly, like that's a high percent, 78 out of 86. So yeah, I would be proud of that. That's a very, very, very impressive score. That means you're looking at like over a 90. So nice job. All right. How many multiple choice to pass? You need, I would say, get like 14, 15 right. I mean, if you look up this Regents, just look up like the conversion chart. It'll tell you. All right, so this I'm going to use the calculator. So y equals, clear out the old stuff, and negative 16 x squared instead of t, and then plus 24. Like this. We press graph, and we could actually see the whole thing. So this one, it looks like it's going up to a height of, let's see. So this one, it's going up to, well, watch this little trick. Second trace maximum is number 4. Enter before, enter after. And this tells us the maximum is at 0.759. Another trick. Ready for this? Second graph, and you're like, oh no, there's no 0.75. You could press second window, and you could change the table for independent from auto to ask. Press second graph, and now you can make a custom table. You could be like, all right, 0, let's say 0.75. See how that gives me the 9? Okay, so that's going to help us through this. But the question is asking, I'm going to press second window, and I'm going to switch back to auto. But the question is asking us here, what's the appropriate domain? The domain is the set of x values. And since we're dealing with a ball being thrown up into the air, and the height of the ball is given by the function h, and t is the time, we're really talking about like when the ball is in the air. This part doesn't make sense because that would be like you throw the ball in the air, but instead of hitting the ground, it just goes through the earth, and it just starts going to like the center of the earth, which would be terrifying if that were the case. So how do we know the root? Well, you could solve this yourself, or little trick, you could graph the line y equals 0 and say, all right, there's the line y equals 0, and press second trace 5 and see, well, just when does this graph intersect with y equals 0? It'll be when x is 1.5. Okay, so I'm going to borrow this. So this is the calculator method. So you're like, hey, so this is clearly the point where x is 0. And this is clearly the point now where x is 1.5, or t is. So domain, appropriate domain is the x values. Okay, and that would be like the t value here would go from 0 to 1.5. This one, just be careful. Like this is referring to the highest y point. So this one's like double wrong because we're talking about the domain, not the range. And the range would be in terms of the function. You know how you get like y equals f of x? So h of t is referring to the y values. So this would be correct. Correct if the question we're asking about range. Okay, if the question was asking for the appropriate range. Okay, but that's not what they were asking for, so choice 1. All right, we made it through the multiple choice. Okay. Oh yeah, one other thing. If you're like, hey, algebra, I love algebra, then you could also go like this. Set it equal to 0, and then you could factor out, you can even factor out like an 8t, because that's the greatest common factor. And then you divide by you divide by 8t. So then like in your head, you're like, all right, negative 16t squared divided by 8t is like negative 2t. So this will make negative 2t plus 24t divided by 8t is 3. And then make this equal to 0. So then you get 8t is equal to 0, which is true when t is 0, but negative 2t plus 3 is equal to 0. This is true when if you add 2t to both sides when 3 equals 2t, or t equals 3 halves, which is equal to 1.5. So you could solve for these, intercepts yourself, but you have a calculator, like save your strength. All right, express in simplest form. So the trap here, look out. Oh yeah, to start, each of these 8 questions coming up are worth 2 credits. Okay, so these are the short ones. All right. So I like to do this vertically. Like if I was doing like, I don't know, pretend it's like second, or maybe this is third grade. I don't know, third grade. Like 538 plus 476. You would probably be told to do this. Like line it up vertically. And you're like 8 plus 6 is 14, carry the 1. 7 plus 3 is 10, plus 1 is 11, carry the 1. And then 1 plus 5 plus 4 is 10. So you're like 1014. Same idea, but now fast forward to, Algebra 1. So what we do here is we write 3x squared plus 4x minus 8. But now we send the negative through. When you're subtracting, the negative has to distribute. Minus 2x squared makes 2x squared. If I do, think of this as like negative 1. Negative 1 times 4x makes minus 4x. And then minus 1 times 2 is minus 2. And now we could add this stuff. So like 3x squared plus 2x squared is 5x squared. 4x plus negative 4x just cancels. And then negative 8 plus negative 2 is minus 10. So here is the answer, simplified. All right. All right, more quadratics. What do you know? All right, so graph this calculator all the way. So you go to y equals, you got negative x squared minus 6x, and now we press graph. You're like, all right, that's what my graph should look like. Please, whatever you do, like students, like the worst answers I've seen, students are like, all right, I got this, and there's like parabola, and I'm like, no, this is 0 points. All right, don't just like parabola and you just swing that, like that's terrible. Okay, so what we want here for accuracy is we press second graph and we look for the turning point in the table. Okay, personally, like, I don't know, what I like to do is I like to copy down the values here. So like if my artwork is a little off, like sometimes that'll just tell the person grading like, oh, this is what they're aiming for, and like maybe they'll be more, forgiving. So this is like x and like your f of x values. So you're like, all right, -7, -7, -6, 0, -5, 5, -4, 8, -3, 9, and then you get -2, +8, -1, 5, 0, 0, and you get 1, -7. Okay, and you just plot these points. So these questions here have the potential to be nice. I mean, you're just like copying points onto the table. You take your time. Okay, so -7, -7. I'm like, all right, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So like that's here. Then -6, 0. Let me get rid of that stray mark. That's 1, 2, 3, 4, 5, 6. And then I'm at 0. -5, 5. So that's here. And then up 1, 2, 3, 4, 5. And then -4, 8. So I'm at 5. And now I go up 6, 7, 8. And then -3, 9. I'm at -3 and I go up 1 more. And this is the turning point here. The vertex is at -3, 9. So this is the vertex. So now I just make use of the symmetry. I'm like, all right, this one, -2, 8. And then -1, 5, 0, 0. And then at 1, we're at -7 again. Okay, so now just carefully I connect. So I go up. Take your time here if you have to. See, like that was sloppy. I'll do this again just till it's neat. All right, it's easier to do this on paper than on a drawing pad. Like here it is. Yeah, like that one. I'm like, I don't like how it looks. Okay, and then I just put an arrow like this to say, hey, this is going to go on forever. All right, and there's the parabola. I would probably sprinkle in like, all right, this is at -7, -6. I don't have to write all of these values in, but you know, if you want to, I think it makes your graph look a little more complete. And I'm at least going up to like all right, like let's say, all right, this is 2, this is 4, so like this would be 5, 6, 7, 8, 9, and then this is like down here at -7. All right, so this is like, you know, sort of just a marker here. But if you look at the model responses, like you don't even need to number your X or Y. Okay, so, oh, bad word. All right, and now I know what it means, so I'm going to start hiding people's bad comments. All right, if you say bad words, I have to silence you. So, yeah. All right, don't say bad things. Okay, state the vertex. So the coordinates of the vertex are at -3, 9. Okay, so there's the, make sure parentheses, you know, that you have to write this. All right, you need parentheses in your answer. Okay, those have to be there. If you just write this, like this is sloppy. Don't do that. Do this. All right, rational or irrational. So this one, square roots of non-perfect squares are equal irrational. Okay, so when I'm looking at this, I'm like, all right, this one's irrational and this one is rational. But when you do a rational minus an irrational, then you're going to get something irrational. Okay, so 7 minus square root 2 is irrational, but explain your answer. So the because, I could say because a rational minus an irrational is irrational. If you're like, what on earth does this mean? Irrational numbers cannot be expressed as fractions. Okay, so if we say like, yeah, those kinds of numbers can't be expressed as fractions. But if I just write it over here, like let's say 7 minus square root 2, see how like there's no pattern here. Okay, like if I had, I don't know, like 7/3, this goes on forever, but it has a pattern. It's just all threes. Okay, if I did 5 plus square root of 16, I have a rational because I have a whole number plus square root of 16 is 4. Like that's a rational number because it's like 5 plus the square root of a perfect square gives me something rational. So rational plus rational equals rational. But if you have an irrational and you add or subtract, I'm sorry, irrational plus or minus rational gives you irrational. All right, let's see. All right. So the value v of t of a car depreciates, which means it goes down in value, according to the function given here. And not repeating numbers. Numbers with no pattern are irrational. So, yeah, so to just expand on that, like if it's infinite, you could still be, repeating numbers are rational. Okay, so repeating is rational. If a number could be expressed as a fraction, it's rational. Like if I had even something like 2/7, may not seem like it has a pattern, but you press math, enter, enter, and you're like, oh, I can make it into a fraction of 2 whole numbers, then it's rational. Okay, so something like 12 over 99 is like 0.12121212, but once again, math, enter, enter, I could write it as a fraction of 2 whole numbers, so it's rational. So infinite decimals that could be expressed as a fraction like this are rational. All right, so now to the car. So remember this formula from before. Remember that A equals P times 1 plus or minus R to the T. But now our formula is going to be minus because we're depreciating. So V of T equals P times 0.85 to the T. But what this tells us is it tells us like we're going to have P times 1 minus R to the T is going to be equal to P times 0.85 to the T power. But this is where your algebra skills come in. When are these two things equal? When inside the parentheses equal. So 1 minus R equals 0.85. And now for this, we could just go minus 1. You could ask the calculator to do this. You get negative 0.15. Then divide by negative 1. So R is 0.15. But state the percent. So ready? Like for this, 0.15 is equal to 15 hundredths. And 15 out of 100 is 15%. Okay, so 15% is our answer. All right, two-way table. A survey of 100 students was taken. Okay, so 100 is the total. It was found that 60 students, so let me go here. 60 students watched sports. Okay, so watched sports, 60 in total watched sports. So I write the total first. And 34 of these students did not like pop music. So the number of students who don't like pop in this category is 34. But this is the total. So I do 60 minus 34 is 26. And that tells us how many that watch sports like pop. All right, so just this on its own completes the first column. All right, now here we go. Of the students who did not watch sports, so that's here, 70% liked pop music. All right, well, they told us in the beginning the total is 100. So the total number of students is here. So if we kind of work backwards, well, they said of the students that don't watch sports, if 60 watch sports and there's 100 total, then we could say 100 minus 60 is 40. So this is 40. But now this is the sneaky detail. Read this again. 70% of the people who don't watch sports like pop music. 70% is the same thing as 70 over 100, which is the same thing as 0.70. So I could take 40 and go times 0.70, and that'll tell us 70% of this. Do this in a calculator, you get 28. Okay, and these are the people who like pop music. So 28 is going here. But now, just do the math, 40 minus 28 is 12. So the missing value here has to be 12. And now we just complete the table. So total going this way, I'm just doing 26 plus 28. 6 plus 8 is 14, carry the 1, and that makes 5. And then here I do 34 plus 12 is 46. And if you add 54 and 46, you also get 100. So that is it. All right. So let's see. I would show your work. If you show no work, you usually just get 1 point. All right, graph this inequality on the set of axes below. So let's see what we're dealing with here. So this one, if I'm doing this, I'm thinking y equals mx plus b. This is the slope, which for these questions, I'm thinking rise over run. So rise over run, and b is the y-intercept. So I want to get this equation or inequality in that form. So I have y plus 4 is less than, and we distribute negative 2 times x is negative 2x, and then negative 2 times negative 4 is positive 8. And we go minus 4. Like this. And this tells us y is less than negative 2x plus 8 minus 4 is 4. Okay, so this is what we're graphing. But our y-intercept is 4. the y-intercept tells us where to begin on the y-axis. So I have 1, 2, 3, 4 is here. So I'm beginning at 0, 4. But now the slope, m, is -2. So I'm going to rise -2. Think of this as just -2 over 1. So I rise -2 and I run 1. So I'm going down 2 to the right 1. And I just keep doing this. Down 2 to the right 1. And I just do this on and on. Let me zoom out so we could actually see here. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. You don't need to put arrows if you go to the end of the graph. Okay, so I could just do this now. I'm all right, now here we go. I'm going dotted because this is like strictly less than. Strictly less than means dotted line. If it was less than or equal to, then solid. So I go here like this. And it's less than, so we shade under. Okay, so I'm shading here like this. Shade under the graph like this. Okay, and that's it. All right. So here we go. So, all right, let's see. So that would be our graph here. Awesome. Okay. So we got next up f of x equals x squared. And yeah, remember people, keep it real in the chat. If I see you saying things that are not nice, I'm going to have to mute people. All right. If I'm like misjudging what I'm reading, it's because I'm doing the math and I'm reading the chat and I'm tired. It's been a long day. But yeah, keep it real. Cool. How do I draw so well on the mouse? I'm using a Wacom tablet. So this is like using a tablet to write. So we have f of x equals x squared and g of x equals x. Determine the values of x that satisfy this equation. So here, f of x equals g of x. You could set x squared equal to x. And determine means, I mean, we could do this a bunch of different ways, but I'm going to go minus x on both sides. So I got x squared minus x is equal to 0. And now I could factor. So I have a greatest common factor of x. So I have x, and I divide everything by x, and I'm left with x minus 1. And now this gives me x equals 0, the first factor, and then x minus 1 equals 0. I set the second factor equal to 0, go plus 1 on both sides, and now x equals 1. Okay, so these are my find the value or values of x that satisfy. It would be 0 and 1. Oh yeah, good luck tomorrow to anyone going to sleep. Good luck, good luck. I know, let's see what time. Oh yeah, 9:08. I'll be done fairly soon. We have not a crazy amount left. All right, so this one. Describe the effect that each transformation below has on the function f of x equals absolute value x, where a is greater than 0. So we have this. Now look, if you forget how to do this stuff, you have a calculator and you just use it. Okay? So you just use it. I just want to see. All right. So here, what we do is we go to the y equals. So I'm just like also monitoring the chat here. So we got math, go to the right, absolute value of x, and a is greater than 0. So if you just experiment, let's say for g of x, see how it's absolute value of x minus a on the inside. So I go here, and let's say I go a is equal to 2. The original function is called the parent function, but the red one moves the graph to the right 2. So it would go to the right a units. All right, g of x is the original f of x. The parent function shifted a units to the right. If I throw the minus a outside, so math, go to the right, like this. So minus 2, it's going to send it down 2 units. See the one in black? It's going down 2. So if you forget, just throw it in the calculator and see. No, don't drop out. All right. Sometimes you lose, and sometimes, you have to like do the level over, and you're still you though. All right. Just hang in there. It's normal to be nervous. I'm trying to make your lives a whole lot easy. That's my goal, is to just get as many of you to pass. What's it called? To get as many of you to pass this as possible. That's my goal, and to get a lot of you to do well also, if your goal is to do well. All right. So here, what we just said before, describe the effect that each transformation below has on f of x. So I could say g of x. I'll say, g of x shifts f of x to the right. And I'll put a in parentheses, a units, so that it's not like shifts to the right, like the word so that it's treated more as like a variable. All right, and I'll say h of x shifts f of x down a units. All right, and once again, just go to the calculator and pick out a random, like we're like, ooh, what happens when a equals 2? And then we see in the calculator, and then we just describe it. All right. So moving on to part 3. Now these are worth more. Okay. All right. So moving on, part 3, 4-point questions, but there's 4 of these. So we have the function r of x is defined by the expression here. Use factoring to determine the zeros. So we want to know, when is x squared plus 3x minus 18 equal to 0? And we have to use factoring. If you say, oh, I graphed it. So let's say you're like, nope, can't factor. So if you, take this. And you've got x squared plus 3x minus 18. You see how it hits the x-axis at -1, 2, 3, 4, 5, 6, and at x equals 3. So I already know the answers are going to be x equals -6 and x equals positive 3. Okay, I know that's happening. So x equals -6 and x equals positive 3. All right, but we need to do factoring to get full credit. But if you're like, hey, I graphed this in the calculator, you get partial credit for writing the answers. Okay, so we're doing this by factoring. We have to find 2 numbers that have a sum of 3, and the 2 numbers also have to have a product of -18. So remember roots and factors, like these are the zeros or the roots. The factors are opposite. So instead of -6, I would have x plus 6, and instead of positive 3, I would have x minus 3, and this is equal to 0. And you can even see 6 minus 3 is 3, and 6 times -3 is -18. But then you set each factor equal to 0 and solve, and it gives you the answer. Okay? Explain what the zeros represent on the graph. All right, so what do these mean on the graph? What do they represent on the graph? The zeros tell us, the zeros. We'll talk about the actual zeros. So we'll say the graph of r of x crosses or intersects the x-axis at x equals -6 and x equals positive 3. Okay? So that's where the graph hits the x-axis. All right, cool. Moving on. The graph below shows Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. Based on the graph, during which interval did Craig most likely drive in the city? All right, this one's like kind of annoying, this question. There's a lot happening here. But we'll just go ahead and, and do it. So here, like you have to think a bit. City versus highway driving Like highway is faster. Okay, city driving is definitely slower because of traffic. All right, New York City people, if you were to drive through like Times Square, you wouldn't really move very fast. Okay, so here the key is to look at the slope. All right, so think slope is the way to go. And here, based on the graph, during which interval is he most likely driving in the city, it's going to be where the slope is less steep. So see how here, like this one, you compare it to like, let's say this one. And then this one is a 0 slope. So he's like not even moving. That's where he's like probably stopped. But if you compare the slopes here, you line them up next to each other. See how like this one is like the slowest to climb? Okay, so that's how we would know that DE is going to be the 2 points. Okay, based on the graph, during which interval did Craig most likely drive in the city? Explain your answer. Well, here, like if I provide evidence, so this is 110. And remember, slope is y2 minus y1 over x2 minus x1. I could find like the slopes, and then I could say like, all right, from A to B is like, and I find it over here. So this is the point 2 comma 110. This is 0, 0. And then this is, let's see, 3.5 comma 110. And then up here is 5 comma 200. And then point E is at 7 comma 230. Okay, so if we, find these slopes from A to B, we're going, think of this as like x1, y1, x2, y2. We're going the difference of the y values over the difference of the x values, and it would be 55. Okay, from B to C, the slope is 0. From C to D, and this I could just see because it's horizontal. I could do 110 minus 110 is 0, but I could just see it's horizontal. From C to D, we got 200 minus 110 over 5 minus 3.5. Okay, and if we work that out, that's 90 over 1.5, and that, I think it's 60, but let me check the calculator. Okay, because these questions, like, yeah, there's a lot of, like, you always want to make sure your answer is, like, precise enough. If you just, like, kind of say, oh, it looks like it, like in math, the numbers make the loudest statement. Yeah, 60. 90 divided by 1.5. So that one is equal to 60. And let me see, I'll move this. Yeah, I'm going to move this here for now, just to give it space. All right, so this from here to here is equal to 60. All right, and I'll get these out of the way. Okay, cool. And then from D to E, we're going 230 minus 200 over 7 minus 5, which is 30 divided by 2, which is 15. And you see how this one is the slowest, okay, like the slowest driving. So based on the graph, during which interval did Craig most likely drive in the city? Explain your reasoning. From D to E. Okay, D to E, because I'll use the word average rate of change. The average rate of change is good vocabulary to know. That's like basically a fancy way of saying the slope is 15, which is smaller than I'll say average rate of change. You could abbreviate like this, AROC. All right. So D to E, because the average rate of change is 15, which is smaller than the average rate of change over the other intervals. Okay. Except, like, B to C. Okay. But I'll say like, what's it? Craig is stopped like from B to C? This is kind of an annoying question here. All right. But D to E is like the slowest. You could probably just get away with saying from D to E because the slope is the least steep. But explain what might have happened between B and C. So, and how much time went by. From B to C, he was stopped for an hour and a half. I don't know. Like Craig stopped for food and gas. Okay, and now determine Craig's average speed to the nearest tenth of a mile per hour for his entire trip. So now we got to find the average rate of change from the beginning to the end. Okay, so for this, and so I'm just like stuck here. All right. So for this one, the average rate of change from the beginning to the end would be from like here to here. Okay, so we're going 230 minus 0 over 7 minus 0. All right, and it's miles traveled per hour. So that's really just miles per hour that we're going to be talking about. All right, so let me now just drag this down. So this is for the last part. Oh, that's annoying that this detached. All right. All right, for his entire trip. All right, although now I could probably just get rid of that because we talked about what it all means. Okay, but it's miles per hour. Okay, so miles per hour. And it's to the nearest tenth. So you just type that in a calculator and you're going to get 32.9. So 32.9 miles per hour. All right, if you want to write mph, that also works. All right, solve the equation g of x equals 2 times k of x algebraically for x to the nearest tenth. And we got to do it algebraically. But this is, once again, if you do this graphically, you get 2 out of 4. Someone mentioned that earlier. 2 out of 4. All right, let's see. Okay. Well, I appreciate the other person teaching me some of the... All right, oh no, I just gotta mute people who are just spamming. Okay, yeah, remember, if you're not keeping it real and you're saying bad words, from before I learned a new bad word today, but I see it. If I see it in the chat, I'm gonna just silence you. It doesn't kick you out. You could still learn, but we all stop listening to you. Okay, cool. So, yep, mute. All right, I would say mods ban them, but no, we'll just silence them. How many questions are left? We're almost there. There's like 3 questions left. Yeah, this one goes to 37. We're almost there. We're going to power through. All right, so g of x, just substitute. G of x is 2x squared plus 3x plus 10. All right, equals 2 times. So see how here it's 2 times, and then k of x, I'm going to write here, k of x is 2x plus 16. So we work this out. 2x squared plus 3x plus 10 equals distribute 4x plus 32. If you do this in the calculator, you get partial credit. Okay? So that's the thing. Yeah, be nice to the teacher. I agree. Okay, so here we get to this part and we move everything to one side. You want this to be in the form of ax squared plus bx plus c equals 0. So you could use the quadratic formula. Okay, so algebraically means you could use quadratic formula. So I'm going to go minus 4x on both sides and minus 32 on both sides. Okay, so this minus x and then minus 22 equals 0. And then from here, we just, we go ahead and we could just use the quadratic formula. Okay, so for this one, I'll just go ahead and plug in. So quadratic formula, I could say, and I'll stay within this range here, a equals 2, b equals -1, c equals -22. We're rounding to the nearest tenth at the end. Okay, so we're going to have x equals -b, but -1 is +1, plus or minus the square root of b squared minus 4 times a times c, and then all over 2 times a is 2. Okay, so this is what we're working out here. So let me just do this and make space. I'm just going to move this stuff up a little bit, though, so that, you know, we're not really struggling here to get through this. All right, so now this one, you've got x equals 1 plus or minus. You have a calculator, but look, the mistake so many people make. You ready? Please don't do this. Don't say -1 squared. It works out to -1. You got to use parentheses. -1 in parentheses squared gives you +1. The reason why these are not the same is this means -1 times 1 to the second power. Remember, parentheses exponents. So you need to write parentheses in the calculator and also show it in your work too. Otherwise it's sloppy. If you want to write the inside, like let's say -1, squared, and then we have -4 times 2 times -22. Like this, we get square root of 177. Okay, so this is, just write this out, of 177, and then this is, make it neater, over 4. All right, so we're going to get two answers. We are going to get x equals 1 plus square root of 177 over 4, which tells us to the nearest tenth, we get x equals 3.6. Okay, so this is our first answer. But we also get x equals 1 minus square root of 177 over 4, which tells us our second answer, which is x equals -3.1. Okay, now this next part is a little annoying. Explain why you chose the method. So this one, I would say I chose the quadratic formula. So I chose the quadratic formula. Well, I'll say I chose to use. I chose to use the quadratic formula because it works to find, or it works for, how do I say this? So this is the sharpen the axe phase, like how to phrase this nice. Kind of an annoying question. But I chose to use the quadratic formula because it will find roots. How about this? It will find, rational and irrational roots. Okay, because if you try to do this by factoring, you're not going to be successful because the roots were irrational. Okay, so that's how I know. All right, question 36. So moving on. So this one's like, yeah, it might be a little outdated because it might be like exponential, but I don't know, exponential is still fair game, I guess. So Michael has $10 in his savings account. Option 1 will add $100 to his account each week. Okay, so this one, if you just think your way through, like mx plus b. So this one's linear. He's starting with $10. Okay, so for this one, he's starting with 10 and he's adding $100 each week. So that would just be, 10 plus 100x, where x is the number of weeks. Okay, they should say write a function in terms of x, where x is the number of weeks. They should define x as that, but they didn't. Okay, and then option 2, the amount doubles at the end of each week. So that would be y equals, he's starting at 10, but then we're multiplying by 2 to the x power. Okay, after 1 week, we multiply by 2 once. After 2 weeks, we multiply by 2 twice. So these would be your two functions. All right, now here, Michael wants to have at least, so this is like, I should say like option 1. I'll just box these off. This is option 1. And this is option 2. Okay, Michael wants to have at least $700 in his account by the end of 7 weeks to buy a mountain bike. Determine which option or options will enable him to reach his goal. So option 1, we plug in x equals 7. And we get y equals 10 plus 100 times 7, which gives us 710, which is enough money. He wants at least 700, so option 1 works. Option 2 would be y equals 10 times 2 to the 7th power. And like this is kind of annoying to do in your head, so I'll just do this in the calculator. So 10 times parentheses 2 to the 7 is 1280. Okay, so this equals 1280. So here the question, once again, if we reread, determine which options will enable him to reach his goal. We could say both options. Options enable Michael to reach his goal. All right, justify means show work. Explain, write a sentence with because. All right, so that's that. Last question, part 4, final boss. 6 credits. So here we go. It's always a system of linear equations. Okay? Central High School has had 5 members on their swim team in 2010. Over the next several years, the team increased by an average of 10 members per year. The same school had 35 members in their chorus in 2010. The chorus saw an increase of 5 members per year. Write a system of equations to model this situation where x represents the number of years since 2010. Okay, so for this one, what we could look at is the, we could say y equals again to model this. So I'll just write it over here. The first one we have is swim. So let's just see. Yeah, the swim team. So for swim, we have y equals, and if we look at this, there's 5 members. So that's 5 plus, and then over the next several years, the team increased by an average of 10 members per year. So that'll be 5 plus 10x, where x represents the number of years. And now for chorus, we have y equals, they have 35 members in the chorus, and this is an increase of 5 members per year, so plus 5x. So that's our system here. 5 plus 10x and 35 plus 5x. Yeah, these are annoying, especially because it's like years since 2010. So like 1 year since 2010 would be 2011. So it's like in reference to a different time period. Okay, so this, I'm just going to drag this down so we could refer to it. Okay, so here, now we have to graph this on the set of axes below. So for this one, and you know what, let me just copy and paste this. So this one, copy, and then paste. And then I'll get this out of here when we're done. But another thing to consider is an appropriate scale. For this one, it jumps out at me to count by 5s because we have 35 here, and we don't have 35 spaces to go. So if you count by 5s, you can say like, all right, this is 10, this is 20, this is 30, we have 40, 50, 60, and then we're just counting by 5s, okay? So every 2 is jumping by 10. So 80, 90, and we can say at the end is 100. All right, and then along the x, for this one, we could just count by 1s is more than enough. If we want to go out more than that, we could see like, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. You know, we could go out, but they didn't tell us which scale to use. So honestly, the first time I did this, I just counted like, all right, 1, 2, 3, 4, and then 5, 6. So I just count by 1s, but I'll just label my axis every 2. Okay, and then 14, and so on. But now I use that rise over run concept. I'm starting my first one here at 5, and I'm going up 10 over 1. My slope, see how my slope is 10. So I go up 5, 10, and then over 1. Up 10, over 1, like this. Okay, I could use the calculator and make a table. You are allowed to do that. But honestly, like after you do a number of these questions, it's like you wind up just doing this and then like going to the end of the graph. Okay, like that. You just graph it to the end. I would label this though. Please label. I would say like, all right, this is y equals 5 plus 10x. I could say 10x plus 5, or I could say it like this. They didn't say mx plus b form. And now 35 plus 5x. So here's 35. See, this is 35. And now I'm going up 5 over 1. So I go up 5. See, my y-axis is going up 5, and my x is going up 1. So up 5 over 1, up 5 over 1, like this. So the scale makes this a little tricky. And there's the point of intersection. Okay, and I just go here like this. Maybe I'll move this label. Okay, I'll move this over, and I'll label it, you know, pointing this way, just so it doesn't overlap with the purple line here. And now you just connect these all. All right, and this would be y equals 35 plus 5x. So this would be our system of equations graphed. And now I'll get this stuff out of here because we already have the equation copied on the first page. But they want us to explain in detail what each coordinate of the point of intersection of these equations means in the context of the problem. Okay, so the point of intersection, we could double check, but this is occurring at 6, and then 65 is the halfway point. Okay, you could graph this in the calculator to double check. Okay, but x, they told us, if you have to go back and read the context, they told us x is the number of years since 2010, and the y value here would be the members. Okay, so the y is the members. Okay, like number of members. And then x is, they told us, years since 2010. All right, so explain in detail what each coordinate of the point of intersection of these equations means in the context. Well, we could say that the two teams here, or what are they? Not teams. Sorry, this is the, oh yeah, the swim team and chorus. The swim team and chorus have the same, you know, I'll write it like this, have 65, comma, the same number of members in 2016, which is 6 years since 2010. Okay, and I'll even like emphasize here that 65 is the y, and then x like is like, you know, like this is the x and this is the y. Okay, and that would get us 100 points on this Regents. All right, well, what I'll say is, for one, thank you all for sticking around this long. I am proud, okay, that you all stayed, you know, this long. Those of you that stayed a long time. If you haven't subscribed yet, please subscribe, okay? And I would greatly appreciate it. Every subscriber counts. But yeah, thank you all for being a part of the 2025 review. If you still need help, I have old Regents solved out from 2025 going far back. But yeah. Oh, Brittany, you're welcome. I recognize your name from the beginning too. Thank you for staying, you know, this whole time. But, you know, good luck tomorrow, everybody. All right. It's normal to be nervous. You know, good luck. But yeah, hang in there and take care.